Good afternoon, students. Are you able to hear my voice? Video is sharing. Yeah, please reply anyone in chat box. I hope that PCV is visible for you, all of you. Okay, so today we are going to discuss about the last topic, indeterminants. That is a very important topic, right? So we have the weightage for the board exam question paper is for chapter 3 and 4, we have 10 marks weightage out of 80. Chapter 3 and 4, matrices and determinants, 10 marks the weightage is given for chapter 3 and 4. Okay, so definitely we have 1 6 mark, right? 1 6 mark is comes from this, mostly in the determinant. Okay, that the second exercise, using properties, we have discussed some problems, that is 4.2 exercise. So that type of problem they may be asked in 6 mark. Otherwise they will ask this applications of determinants. That means that is we are going to now discuss. So therefore we can definitely expect 1 6 mark problem in this determinant, section D problem. Okay, so that may be either in that 4.2 exercise related problem, using properties we have to prove some determinants, that type of problems. Or now we are going to discuss about this type of problem also will ask in 6 marks. You see the previous year question papers, board question papers, you will get an idea. So in which chapter, which marks are given, which marks are they asking, okay, what is the weightage of the chapters, everything will know, you will know that. Okay, right. So now we are going to discuss about applications of determinants and matrices. Applications of determinants and matrices. Okay, right. The application of determinants is, we are going to apply the system of solving the system of equation using determinants and math. Okay, so using determinants we are going to solve the system of equation. Okay, so therefore a system of equation is said to be consistent. First definition you have to understand, a system of equation is said to be consistent. A system of equations is said to be consistent is said to be consistent if its solution exists. If its solution exists. Solution means one or more, either one solution or more solutions. Sometimes we'll get only one solution, that is called as unique solution. Sometimes we'll get more solutions, more than one solution, that are called as infinite number of solutions. Okay, many solutions. Okay, one or more solution exist means then the system is said to be consistent. The system of equation is said to be consistent. Okay, right. So what is inconsistent? A system of equation is said to be inconsistent if its solution does not exist. You please take the next definition. A system of equation a system of equations is said to be inconsistent if its solution does not exist. Okay, right. Now consider the system of equation a1x plus b1y plus c1z equal to d1. Now take the second equation a2x plus b2y plus c2z equal to d2 and a3x plus b3y plus c3z equal to d3. Consider the system of equations. Okay, now collect this coefficients of x. What are the coefficients of x? A1, A2, A3, coefficients of x. Okay, similarly coefficients of y. What is your coefficients of y? B1, B2, B3, and coefficient of z, C1, C2, C3. Okay, into these unknowns. What are the unknowns? X, Y, Z. So therefore this is X, Y, Z equal to, so this is D1, D2, D3, D1, D2, D3. Okay. So look at that, your A1, B1, C1, A2, B2, C2, A3, B3, C3. If you multiply these two matrices, A1x plus B1y plus C1z equal to D1, we will get the first equation. Similarly, second, A2x plus B2y plus C2z equal to D2. You will get the second equation, A3x plus B3y plus C3z equal to D3. You will get the third equation. Okay. So therefore, we will get that three equation. We can represent these three equation in the form of matrix multiplication. In matrices, we can represent the system in matrices also. Now consider this is your A matrix. Okay, your A1, B1, C1, A2, B2, C2, A3, B3, C3. So this is your coefficient matrix. Take it as capital A. This is unknown matrix. Your unknown matrix is take it as capital X. And this right hand side we have some values d1, d2, d3. You can take it as this is matrix B. So therefore this matrix representation can be written as Ax is equal to B. What is your A? This is your A. What is your B? This is your, sorry, X. This is your B. D1, D2, D3 is our B. Okay, right. Now this system may have solution or may not have solution. Sometimes this system having solution, sometimes having one solution, sometimes having many solutions, sometimes having no solution. How to find out that? Okay, so come to the first case, case 1. Okay, if A is a non-singular, if A is non-singular, what is non-singular? Determinant not equal to 0. Determinant not equal to 0 means what happened? A inverse exists. A is non-singular, then A inverse exists. Okay, A is invertible, then A inverse exists. Inverse of A is exist. Okay, then what is the purpose? What is the use? So look at that. This is we have A x is equal to B. right? A is a given matrix, B is also given one. We have to find out your X. Okay, so I'm going to multiply both the sides by A inverse. If you multiply by A inverse, what happens? A inverse into AX equal to A inverse into B. Pre-multiplying A inverse both the sides. Okay, so therefore, using associative law, I can interchange the bracket A inverse into A. What is my A inverse into A? That is identity into X. Identity into X matrix. A inverse into A is identity into X is equal to this A inverse into B. Okay, so therefore identity into X. Okay, so identity into X is X only. Okay, so therefore I into X is equal to A inverse into B. Right. So what is your I into X? That is X only. Identity matrix into any matrix, that matrix itself. So therefore we will get A inverse into B. Your A inverse exists. Look at that. Your A inverse is exist. Okay. Right. So this matrix equation provides unique solution for the given system of equation as the inverse of the matrix is unique. Okay. So therefore, since this inverse is unique, look at that. A is non-singular means inverse of A is exist. A inverse exists. If A inverse exists, that must be unique. Your A inverse is unique. What is the meaning of A inverse is unique? Only one inverse matrix exists for A. Okay, if you A inverse is non-singular means only one A inverse exists. It is not possible to find out another inverse. A inverse. Okay, only one inverse exists. If exists means it is only one, unique. So therefore, since this is unique, this A inverse is, since this A inverse is unique, okay, so therefore we will get unique solution. Since A inverse is unique, since A inverse is unique, X having the unique solution. This matrix equation provides unique solution. We have unique solution. Unique solution means only one solution. Okay, since A inverse is unique, we have unique solution only. Right, come to case 2. What happened for case 2? A is non-singular, that is case 1. If A is singular means what happened? If A is singular, then determinant of A is equal to 0. Right, so find adjoint of A. For this determinant of A is 0, we can find adjoint of A. It is not possible to find determining inverse of A. Inverse of A is not possible, it is not exist. Okay, but adjoint of A exists for all the matrices. Okay, so therefore, if in this case, if adjoint of A into B, find adjoint of A and multiply by B matrix, this is not equal to 0. If your adjoint of A into B, what is your adjoint of A? The adjoint of this matrix A. What is your B? Your B is this matrix. This matrix D1, D2, D3. This is the adjoint B matrix. Multiply this adjoint of A into B. That is not equal to 0. Then the solution does not exist and the equation inconsistent. Then solution does not exist. Okay, then solution does not exist. Okay, and the system of equation is called inconsistent. System of equations is called inconsistent. Okay, when it is inconsistent, adjoint of A into B is not equal to 0, then the system of equation inconsistent and solution is does not exist. Okay, sir, if adjoint of A into B is equal to 0, then what happens, sir? Is equal to 0, then the system may be either consistent or inconsistent. Okay, as the system having infinitely many solution or no solution. Right, if adjoint of A into B equal to 0, then we may get infinite number of solution. We may get infinite number of solutions. Infinite number of solutions or no solution. Okay, please note that if A is non-singular, definitely we will get only one solution, unique solution. If A is singular, sometimes we may get infinite number of solution or no solution. Okay, if adjoint of A into B is not equal to 0, definitely the solution, the system of equations inconsistent and no solution exists. Okay, but if A adjoint of A into B equal to 0, then we may get infinite number of solution or no solution. Sometimes we may get solution, sometimes we may not get solution. So therefore, if the no solution is does not exist means the equations are called as inconsistent. Solution exists means that is consistent. Okay. Here definitely please note that here definitely for this case definitely inconsistent. Adjoint of A into B not equal to 0 means definitely inconsistent. Okay, if your adjoint of A into B equal to 0, right, sometimes solution exists, sometimes no solution exists. Okay, there are three cases, please try to understand. If A is non-singular, we get in unique solution. If A is singular means we have two cases. One is inconsistent, no solution. The other another one is this. In this case, we may get solution. That means infinite number of solution, or we may get no solution. Infinite number of solution means the system of equations are called as consistent. No solution means the system of equations are inconsistent. Okay, so we'll discuss some problems. Okay, next question is, problem is, solve the system of equation solve the system of equations 2x plus 5y equal to 1 and 3x plus 2y equal to 7. 2x plus 5y is equal to 1, 3x plus 2y is equal to 7, right? So now look at that. So I'm going to write that coefficient matrix. What is the coefficient of x? Write the coefficient of x in the first column 2, 3. Coefficient of y is 5, 2. Okay, into unknowns. What is your unknowns? What are the unknowns x and y? And right hand side values, take it as 1, 7. Okay, now this is your a, this is your x, unknown matrices, take it as x, and this is your b. Okay, what is your a and b and c? Write that, where your a is equal to 2, 3, sorry, 2, 5, 3, 2. Okay, what is my x? My x is unknowns, x and y, and my b, not y, b. B is equal to 1, 7. Okay, right. So what is the equation we have already discussed in the first case? First of all, check the determinant of a. What is your determinant of a, singular or non-singular? What is determinant of a? Determinant of a is equal to 2 into 2, 4. Okay, this is minus 15. So the answer is minus 11. Determinant of a is not equal to 0. Not equal to 0 means a is non-singular. Look at that. First case, a is non-singular means a inverse exists, we will get unique solution. If a is non-singular, we will get unique solution. So since a is not equal, determinant of a is not equal to 0, we will get unique solution. How to find out your unique solution? That is a x is equal to b. Okay, multiplying, pre-multiplying a inverse both the sides, pre-multiplying here also a inverse, here also a inverse, and then simplify, I will get it as, so a inverse into b. Okay, right. First of all, find A inverse. What is your A inverse? Find A inverse and multiply by B, that you will get the unknown matrix. Okay, so how to find out your A inverse? My A inverse is equal to 1 by determinant of A, adjoint of A. First of all, find adjoint of A. What is your adjoint of A? I have already found out that determinant of A. Determinant of A is minus 11. Okay. So my adjoint of A is equal to, how to find out adjoint of A? I have already told that interchanging these two elements, sign changing of these two elements. What is the sign change? Minus 3 and minus 5. Okay, so interchanging of these two elements and sign changing of these two elements, right? So what is your A inverse? Your A inverse is equal to 1 by determinant of A, adjoint of A, minus 1 by 11, determinant of A, right? First of all, write the formula. What is A inverse formula? 1 by determinant of A, adjoint of A. Okay, so therefore 1 by determinant of A minus 11, adjoint of A. What is my adjoint of A? 2 minus 5 minus 3, 2. Okay, so therefore this is my A inverse. Now what is the solution? Unknown matrix is equal to A inverse into B. So now therefore come to that, 1 implies x is equal to A inverse into B. What is my A inverse? My A inverse is minus 1 by 11, 2 minus 5 minus 3, 2. Okay, into B. What is my B? My B is, look at that, 1 and 7. Now multiply these two matrices. Matrix multiplication is possible. You check that this is 2 cross 2 matrix, this is 2 cross 1. Your number of columns here and number of rows here both are same. Here also columns 2, here number of rows 2, therefore both are equal. So therefore matrix multiplication is possible. Multiply. Multiply these two. So take this, your x is equal to minus 1 by 11 of, what is the multiplication of a and b? So this is 1 into 2, 2. This is minus 5 into 7. Okay, so therefore this is minus 35. This is plus 2. So the answer is 2 minus 35. Here 1 into 2, 2 minus 35. Similarly, this is minus 3. Okay, this is 2 into 7, 14. Okay, so minus 3 plus 14. So this is minus 3 plus 14. Okay, now minus 1 by 11. 2 minus 3 means minus 33. And minus 3 plus 14, that is 7. This is minus 33. Now divide by minus 11. So now they multiply this minus 1 by 11 inside, minus minus cancel, 33 by 11. Okay, so minus cancel, you will get 33 by 11. 33 by 11 is 3 only. And 11 by 11 it is 1, but minus is there. So therefore we will get minus 1. Okay, right. Now what is the x? Actually, what is the x? Unknown matrix. What are the unknowns here? We have x and y. So these two matrices are equal. If these matrices are equal, then the corresponding elements are equal. So therefore, the corresponding elements are x is equal to 3, y is equal to minus 1. Okay. Yeah, please take that. We will go for the next problem. Are you okay? The next problem is solve the system of equation by matrix method. Solve 3x minus 2y plus 3z equal to 8, 2x plus y minus z equal to 1, 4x minus 3y plus 2z equal to 4. Okay, so first of all, write the coefficient matrix. What is the coefficient matrix? A matrix. What are the coefficients of x? 3, 2, 4 coefficients of x. What about y? Minus 2, 1, minus 3. And this is 3 minus 1, 2. And unknown matrix. What are the unknowns? X, y, z. That's equal to, okay, this is 8, 1, 4. Okay. This is 814. Now, what is where this is where a, this is where x, this is your b. Therefore, ax is equal to b. Right. So now go for a, determinant of a. Check that a is singular or non-singular. So expand the determinant along the first row. Row 1. This is plus 3 into this is plus minus plus. Okay. So plus 3 into multiplication of this. This is 2. This is minus 3 into minus 1, that is plus 3, but we have another minus, that is minus 3. And this is minus of minus 2. Here we have one minus, prefix minus, and this element is minus 2. Okay, and take it minus of minus 2 and leave this column and leave this row. So the remaining is 2 minus 1, 4, 2. Then multiply these two. So that is 4 minus, this is minus 4. This is 2 into 2, 4. This is minus 4, but already we have one minus. Okay, so therefore this is plus 3. Next term, third term, this is plus 3 into, this is 2 into minus 3, minus 6. This is 1 into 4, minus 4. Right, now simplify this. What is the answer? Here 2 minus 3, it is minus 1. Minus 1 into 3, it is minus 3. And this is minus into minus plus. And here also minus into minus plus. 4 plus 4, 8. 2 8s are 16. Okay, and this is minus 10. Right, 3 into 10. 3 into minus 10, minus 30. Okay, so therefore the answer is minus 3 plus 16. And minus 30, so therefore this is minus 33 plus 16, so therefore the answer is minus 17. This is not equal to 0. Not equal to 0 means your A is non-singular. Non-singular means you will get unique solution. Okay, so unique solution means we'll go for that x is equal to so some students please look at that. So Saturday, 12:30 p.m. Saturday tomorrow, 12:30 p.m. That is a career counseling meeting is there. Tomorrow, 12:30, career counseling meeting is there. There is a talk by some students from NELSAR. Okay, you please try to attend that meeting. Okay, so here career counseling Zoom ID is also given. Link is also given. Okay, so I don't know how to forward this. So anyway, you will get it. Right, so tomorrow, Saturday, career counseling meeting at 12:30 is there. There is a talk by some students from NELSAR. Okay, so you please try, attend that meeting. That will be very useful for you. Okay. Right, so here the determinant is not equal to 0. Not equal to 0 means you will get that unique solution. Unique solution means you go for that x is equal to A inverse B. Right, find A inverse. Okay, how to find, what is the formula? That is x is equal to A inverse B. Okay, so find A inverse. How to find out A inverse? Right, so what is your A inverse? 1 by determinant of A adjoint of A. Okay, right, so I'm going to determinant of A, already got it. I'm going to find out the adjoint of A. How to find out the adjoint of A? I'm going to find the adjoint of A directly. Okay, First of all, what is your A? Your A is 3 minus 2, sorry, 3 to 4, first column, x values 3 to 4, minus 2, 1, minus 3, 3 minus 1, 2. Okay, so now find out the minor of this element. How to find out the minor of this element? Leave this first row, leave this first column, take the minor. Minor means take the determinant of these 4 elements. What is the answer for these 4 elements? Determinant of these 4 elements, that is, this is 2, and this is minus of minus, minus into minus plus, but again we got one more minus. So therefore, 1 into 2, 2, 2 minus 3. The answer is minus 1. Look at that, I am just writing minor only. Okay, right. And find the minor of this element. What is the minor of this element? The minor of this element is leave this column, leave this row. What is that? 2 into 2, 4. This is minus of minus 4. That is plus 4. I will get 8. Okay. So this is minor. I am writing just minor only. Right. Now come to this element. Leave this column, leave this row. So therefore this is minus 6, minus 4. I will get minus 10. This is minus 6, this is minus 4, I will get minus 10. I am writing minor only, please try to understand. After that, I will make this minus 2 cofactors, okay, and take a transpose, I will get an adjoint of A, right? Now come to this element, leave this column, leave this row, I will get minus 4, this is plus 6. So therefore, the answer is, here I am leaving this is minus 4, okay, this is plus 9, sorry, this is plus 9. Minus 3 into 3, that is minus 9. We have already one more minus. So therefore plus 9. Minus 4 plus 9. Okay, so this is minus 2, 3, minus 3, 2. Take a determinant. This is my minor. Okay, what is the answer? This is minus 4 minus half. This is minus 3 into minus 3. It is minus 9. So therefore minus 4 plus 9. So therefore the answer is 5. Plus 5. So therefore here I am getting plus 5. Okay. Similarly, come to this element. How to find out the minor of this element? Leave this column, leave this row. So remaining 4 elements determine this is 3 2s are 6. This is minus 12. So plus 6 minus 12 means that is minus 6. Okay, come to this element, leave this column, leave this row. This is minus 9. This is plus 8. 4 into minus 2, that is minus 8, but again we have one more minus, therefore plus 8. So minus 9 plus 8, therefore the answer is minus 1. Okay, now come to this element, leave this column, leave this row. This is 2 minus 3, that is minus 1. Okay, and this element, so leave this column, leave this row. What is the answer? Minus 3 minus 6. This is minus 3 minus 6. Okay, so 2 into 3, 6 minus 6. So therefore minus 3 minus 6 means we will get minus 9. Okay. And the last element, this element minor is, this is 3 minus of minus plus 4. So therefore 7. Okay, these are the minor values. Okay, sir. Okay, so if you multiply here by plus, minus, plus, okay, minus, plus, minus, plus, minus, plus. If you multiply plus minus plus minus plus minus, that are called it as cofactors, and take a transpose, that is where adjoint of the matrix. So therefore, if you multiply plus means what is the answer? Minus 1. Here it is minus 8. The next one is minus 10. Okay, and minus 5 and minus 6 plus into minus, minus 6. This is minus into minus plus 1. Here also minus 1. Here it is plus 9. Okay, here it is 7. Okay, right. So take a transpose, that is important. So therefore your adjoint of A is equal to, take a transpose. Your adjoint of A is equal to -1, -8, -10, okay, and -5, -6, 1, and -1, 9, 7. This is my adjoint of A. What is your inverse? Your inverse is equal to -1/17 because your determinant A is -17. Okay, and this is -1, -8, -10. This is -5, -6, 1. This is -1, 9, 7. This is by A inverse. Okay, now apply that in X is equal to A inverse B. Okay, what is for X? X is equal to A inverse into B. What is your actually A inverse? -1/17. Okay, what is the A inverse? -1/17, -1, -8, -10. Okay, and -5, -6, 1. And -1, 9, 7. Into B matrix. What is your B matrix? The B matrix is, this is 8, 1, 4. Now multiply -1/17. You don't multiply this now. Finally, we will multiply that -1/17. So now you multiply these two matrices. Okay, multiply. What is the answer we are getting? So this is -8. This is -5. Okay, and this is -4. So therefore, -8, -5, -4, and this is -64. This is -8 into 8 plus 8, -64. This is -6 into 1, -6, matrix multiplication, 9 into 4. So that is plus 36. Okay, this is -10 into 8, -80, and 1 into 1, that is 1, and 7 into 4, 28. So therefore, so this is -1/17 into, so this is -8, -5, -13, -4, that is -17. Okay, this is -64, -6, -70, okay, plus 36. So therefore, -34. Right, this is -80, and this is plus 29. Okay, so therefore, the answer is -51. Now multiply this -1/17 here. So therefore, the left hand side is X matrix is X, Y, Z. Right hand side, if you multiply this -1/17 here, -17 into -1/17, the answer is 1. Okay, here this -17, -1/17 into -34, minus cancel, 34/17, it is 2. Okay, and here it is 3. So therefore, the answer is your X is equal to 1, Y is equal to 2, Z is equal to 3. So these are the solutions of X, Y, Z by matrix method or determinant method. Okay. So once if you complete it means we will go to the next problem. Right, the next problem is if A is equal to 2 minus 3, 5, 3, 2 minus 4, 1, 1 minus 2, find A inverse using A inverse solve the system of equation. That is 2x minus 3y plus 5z equal to 11. This is 3x plus 2y minus 4z equal to minus 5. And this is x plus y minus 2z equal to minus 3. So find A inverse. Using A inverse, solve the system of equation. First of all, find the A inverse for this problem. Try to find out the A inverse. Find the determinant first. What is the determinant value? This is 2 into, okay. This is minus 4. I'm finding the determinant minus 4. This is 1 into minus 4, but we will get plus 4 because we have another minus is there, okay. And minus of minus 3 into, right? So leave this column, leave this row. So therefore 3 into minus 2, minus 6, okay. And this is minus of minus plus 4 plus 5 into, okay, leave this column, leave this row. So therefore this is 3 minus 2. So therefore this is 0. This is minus into minus plus 3 into minus 2. This is minus 6 plus 4, that is minus 2. This is plus 3. Okay, this is 3 minus 2, it is 1. 1 into 5, 5. Right? This is 3 minus 2 means minus 6 plus 5. The answer is minus 1. Not equal to 0. Not equal to 0 means A is non-singular. Non-singular means inverse exists. Inverse exists means we will get an unique solution. Okay, right. So, but here we have to find out that A inverse first. First of all, find the A inverse. To find the A inverse, find the adjoint of A. Adjoint of A. For finding adjoint of A, first of all, find the minus. Write the minus in same order. Okay, and multiply by plus minus plus minus plus minus plus. First element by plus, second element by minus, plus minus plus minus logic. Okay, you will get cofactor matrix and take a transpose of this cofactor matrix, you will get adjoint of A, right? So you can easily find out your adjoint of A. So I'm just writing the adjoint of A. You please check the answer. You will get 0 to 1, minus 1, minus 9, minus 1, minus 9, minus 5, 2, 23, 13. Okay, take a transpose. What is the transpose of this matrix? This is 0, 2, 1. Okay, this is minus 1, minus 9, minus 5. This is 2, 23, 13. Right? This is my adjoint of A. You check that. Please verify. Okay. So now what is your A inverse? My A inverse is equal to 1 by determinant of A, that is minus 1, into adjoint of A. What is my adjoint of A? My determinant of A is minus 1. Adjoint of A is 0, minus 1, 2, and 2, minus 9, 23. 1, minus 5, 13. Okay, this is my adjoint A inverse. That is a first question. Find A inverse. Okay, so therefore this is the answer. You multiply this minus also inside. If you multiply minus 1 here, you will get 0, 1, minus 2. This is minus 2. This is plus 9. This is minus 23. Okay, and here it is minus 1, plus 5. Okay, minus 13. Okay, so it is better you can keep minus 1 outside, or you can multiply inside. Both are correct. Right, now come to that, the equation. What is the equation? This is the system of equation is given. First of all, write the coefficient matrix. You will get the coefficient matrix is okay. Look at the coefficients of x. Coefficients of x is 2, 3, 1. Here coefficients of y is minus 3, 2, 1. Okay, and z 5, minus 4, minus 2. A into unknown matrix. What is my unknown matrix? X, Y, Z. Okay, right. What is my B matrix? 11, minus 5, minus 3. 11, minus 5, minus 3. Okay, so this is my A, right? This is my X. This is my B. Now look at that. This 2, minus 3, 5, 3, 2, minus 4, 1, 1, minus 2 is nothing but this matrix. 2, minus 3, 5, 3, 2, minus 4, 1, 1, minus 2 is nothing but this matrix. Okay, for this matrix we have already find out our A inverse. This is my A inverse. Okay, so therefore we can, this determinant is also not equal to 0. We will get unique solution. Therefore we can take it as x is equal to A inverse B. Okay, we can take this A inverse as this 0, 1, minus 2. This is my A inverse 0, 1, minus 2, minus 2, 9, minus 23. Okay, minus 1, 5, minus 13. Okay, into the B matrix. What is my B matrix? 11, minus 5, minus 3. Okay, now multiply. What is the answer? So this is 0, this is minus 5, this is plus 6. 0, minus 5, plus 6. Similarly, this is minus 22, minus 2 into 11. This is 9 into 5. Okay, so therefore minus 45. 9 5s are 45. This is, so this is your 9 into minus 23 into 3. Okay, so therefore minus 23 into 3 means that is plus. So therefore 69. So minus 23 into minus 3. So therefore minus into minus plus 3 into 23. So therefore this is 69. Okay, and come to the third row. This is minus 11. This is plus 25. 5 into minus 5. This is minus into minus plus. This is 39. Okay, now what is the answer? So this is plus 1. Okay, this is, look at that. This is actually minus 45 minus 22 means minus 47 minus 57 minus 67. Minus 67 plus 69, the answer is 2 plus 2. Okay, and look at this. This is actually, this is minus 25. This is minus 25 minus 11. What is the answer? So therefore this is minus 36. Minus 36 plus 39, what is the answer? It is 3 only. So therefore I will get 1 2 3. What is our left hand side? X Y Z. So therefore the conclusion is your x is equal to 1, y is equal to 2, z is equal to 3. Okay, so therefore this is the answer. Please note that. And your homework problem is exercise 4.6. Try to complete that exercise 4.6. All the problems are based on this only. Try to complete that homework problems. If you have any doubt means, you please ask your doubts, send your doubts. Okay, we will discuss. I will explain. Okay, thank you all. Thank you so much. We'll meet in the next class. Karthik sir, thank you.